Alright.
Oh, I see matches.
We're gonna burn this mother down. Okay, so first things first, just want to be clear, I'm not looking for any kind of like right answers or anything like that. So like don't worry about whether you know it or not.
Okay.
The only thing I want to know is how you think. Like what do you think's going on in all these processes? I'm gonna be asking you some questions about like different things of where energy goes and like where you think it goes and what happens. So just relax, no worries. Got the beer, we'll be set. Alright. Let's see. Let's start off. Oh, wait, there's one more thing I was supposed to say, I think. Oh, yeah. What science classes have you taken? And also, what's your major?
Science. What time frame are you looking for? Like high school or like just
in
college?
your life. Let's go high school to college.
Okay, I did take a high school physics class. And in college, I've taken biology classes, biology 1 and 2, just general, and that's about it for sciences.
Okay. And what's your major?
I'm in public relations and mass communication.
Right on. All right. That and do you have a problem being recorded?
No.
Cool. And are you cool with this being used for like research purposes, possibly?
Yes.
All right. I'm gonna have you sign a consent form when we're done.
Oh.
Yeah, that's scary. All right. Where's my pencil? All right. So first things first. Got a match. So basically, how does this like?
Okay. Well, there's friction,
Okay.
and then I'm gonna assume that there is a reaction with the oxygen in the air.
Okay. So what kind of energy do you think's going on here?
That is not kinetic, but kinetic.
Okay. What do you mean kinetic? Can you describe
Like
that?
it's happening. It's currently happening. It's not being stored. It's happening.
Okay. So was there energy in this before the match was lit?
No.
No. Okay. Why?
Because I only know of kinetic and potential energy.
Okay.
Maybe I don't think so.
I don't think so. You were saying maybe potential. What were you thinking there?
I was kind of rethinking because potential energy means that it's potentially gonna happen. It could it has all the elements to do it, but it's not doing it yet.
Okay. So
But you needed the friction to do it.
I need the friction. Okay. Do you want to try and do it?
Yeah.
And see if you can think anything more. Like, do you think? So do the.
Well, maybe because I'm holding it here.
Finally doing it.
I don't know. I'm kind of torn here.
Torn between what? What are you torn between?
If there's any energy when it's not lit up yet, when it's just here.
Okay. And what's the other part you're torn between?
Well, I definitely know that that's like a sort of kinetic energy when it's just happening. It's not potential, definitely not potential
Okay.
at that point.
Okay. Cool.
That's all I.
So I think. So do you think that did these matches in here have energy right now?
No,
No. Okay. Why do you think that?
because they're not doing anything. They're not.
They're just sitting there.
They're just sitting in there.
Okay. Cool. Let's see. So, do you think that there's any kind of transfer of energy? Maybe like
From the stick to the box, or
anything
the
at all?
box to the match.
Any-
A transfer of energy. Um,
You can light as many as you want.
um,
Uh-oh. These matches suck.
There has to be, in order to like this, in order for this to be lit, there has to be something.
What's that
happening.
something? Something happening?
Something's happening for
Okay.
this to be lit. But that's the friction.
That's the friction. Is friction energy?
Yeah.
Oh wait, why do you think that? Like what makes you like? Where'd you come up with that?
Because it causes something. It causes an effect.
Okay. Like what? How so? Like what effect?
It's lighting it. It's lighting. It's creating like heat, and that's
Okay.
what matches. That's what lights the match.
Okay. And so then, when the match burns out, like, is there? So you're saying there's energy right now.
Yeah.
Okay. So is there energy when the match burns out, or where does it go, if it does? Oh, the smell of matches.
And I'm a pyromaniac. Is there
Good.
energy when the light goes out? When the flame goes out? No.
Okay. So where'd the energy go that was there then?
It just.
Like, where do you think it went? Like I said, there's no right answers.
Where did it go? It. Never thought about that. It. Because it burned out. It's making me think.
That's a good thing.
I wonder. I know. Is there still energy in it? No. It's just a little wooden stick now. There's nothing on it. There's nothing. It's burnt out.
Okay, so it has the same energy as one of these matches now? Like one of the ones that isn't burned yet?
Yeah, because I said that these didn't have energy.
Okay.
Because there's nothing. I don't think it has energy until it
Till it's actually
it
there.
makes contact.
Okay. So let's see. Ow, son of a gun. Okay. So you think that there's no energy until you make contact.
Right.
So is the contact the energy, or what's starting that?
I think the contact is the energy. That friction is it's making that.
Okay. Okay, so the friction is what's causing the energy to start.
Yeah.
So, and the energy is what in this situation? Would you say it's the flame, like how would you view the energy when you're just looking at it burning?
Yeah, that flame. That
Okay.
flame is the energy. Because
Okay.
other than the flame, it's just a stick with whatever chemicals are on it. I don't even know what these are made out of.
Okay. So, let's see. So are the sticks burning?
What?
So like you say the stick, so the flame's the energy, right? Where
Right.
is the flame getting energy from?
The air around it, or the oxygen around it, I think.
It's just getting from the oxygen. Okay, so
I think that's what's making it. No, whatever this is making it burn. And then the air around is kind of what puts it out, I think. Otherwise, it just keep burning.
okay. Well, what happens? So let's do it. Let's burn one.
See, it's burning.
I hold it upside down so we can actually keep it going. Okay, so now
Well, now the
hold it
flame's
straight.
getting bigger. Now the stick's on fire.
So is there more energy?
It's getting larger. How is that happening? It just keeps going.
So this little green stuff isn't actually on the whole stick, right?
No, and it continued to burn. Once it started, it keeps going.
Okay, so how's it doing that?
Like a chemical reaction or something with the air, with whatever chemicals or whatever gases are in the air.
Okay. What gases do you think are in the air?
Oxygen. I think this is letting out carbon monoxide. I don't know. I'm so stupid.
You're not stupid. No. Don't say that. This is you thinking.
This is letting out. It's letting out its own gases and reacting with the gases that are already in the air. And
so it's burning the gases. Is that where the flame's coming from, or
it's reacting with the gases.
what's reacting with the gases?
The flame.
So what's causing the flame? Like what? So the flame's is reacting with the gases to make the flame bigger. Is that what or what are you?
To keep it going.
Okay, so you're saying the initial start?
Yeah, that contact with with all that friction is what starts it, and then what keeps it going is the energy that's there. Once it starts, it's just.
And where's that energy at? That's you said the energy that's there. So I'm just trying to figure out. Is it like?
I feel like I'm creating. No, because you can't create energy. I don't think it's there already.
Okay. So it's there already.
So
Wait.
that means that they have energy.
Would it? I mean, that's what you're.
Maybe they have energy.
Okay.
But what kind of energy would that be called? That's where because if I remember correctly, and I probably don't, because I'm thinking back to like elementary or something. Potential energy is energy that's stored and that needs like an outside force act on it or something. I'm not really, but
it's okay.
I can't remember. And I know kinetic energy is like, in a way, something that's like happening. Like,
okay.
I don't remember though.
No, that's fine. Hey.
I don't remember.
Hey, you're good. So, but you're now saying that you think the sticks do have energy.
Like a stored energy, maybe.
Okay. And so. Okay.
A stored energy, and then doing this makes it kinetic or something.
Oh, okay. The act of you striking it.
Yeah.
Makes the kinetic. And so then what happens to it?
When it burns out.
While it's burning.
While it's burning.
What kind of, is that kinetic energy or?
Yeah.
Okay. Why do you think that?
Because it's not potential, and I only know potential and kinetic.
Hey, there you go. You go with what you know. All right, cool. So you think that? So what we're saying is that the sticks have a potential energy, and then the act of you, striking it with the friction, causes it to become kinetic energy. And then while it's burning up, we still not sure what's happening to it after it burns, right?
Yeah.
Okay.
I don't know where it goes.
Okay, cool.
I don't know if there's a type of energy where it just stops.
What's happening as it's burning? What's going on? Like it's when it burns. Like what do you observe happening? So let's see.
It's like eating away.
What's it eating away
at the stick and what it's made out of, what it's consuming there.
Okay.
It's turning it into a different. It's not a stick anymore after that. It's like ash and black stuff.
Okay. So there's energy. So energy's leaving it right now. Is that what you're saying?
Yes.
Okay. Where's it going? Don't know.
I don't think the energy's not transferring anywhere.
So you're saying it's the same amount of energy in the stick now as there was before we struck it?
It's dead.
It's dead.
It's dead. I don't think so.
So there's no energy. So this has more energy than this.
Yes.
The unstricken match.
Because you can do something with that. You can't do anything with that anymore.
Okay. And you not sure where it goes?
Mm-mm.
It's just gone.
It just disappears.
Just up and left like my daddy went to the store. Okay, cool. Well.
Jeez.
Jeez, what?
I've never had to think this hard before.
Sips beer. Okay, this is a fun one. Okay. Which one do you think is colder?
Do I touch him?
Mm-hmm. Go ahead.
This one.
This one feels colder?
Yeah. Mhm.
Okay. So, let's see. So this one's colder than this one?
Yeah.
Alright, cool. Well, let's, I'll be right back.
I know. Let me go fast now.
Go. Okay. So, we said this is colder. Which one do you think is going to melt the ice cube faster? The colder one or the warmer one?
I'm gonna assume that the warmer one would.
Okay.
Oh no! What?
I'm going to grab a paper towel.
We don't have any.
We'll grab a towel.
What?
So, what do you think's going on? Like, we said this one was colder.
How's that happen? I've never seen the ice cube melt that fast. What are these?
This is just a metal plate and it's plastic. So, what if I told you that these two plates were the exact same temperature?
I wouldn't believe you.
Wouldn't? Well, we got temperature again. So let's see. So this one we think is colder, right?
Mm-hmm.
What's that say?
74.6.
Okay. Oh, this is shitty. That's not supposed to be.
It's colder,
Whoop.
for the record.
Yeah, right? Probably because the ice is already on it.
It's true.
So I probably should have measured the temperature before I put the ice on.
But still, even if this is showing up as colder on there, but it's still, I don't know, it's melting the ice really quickly. That was crazy.
So
I've never seen that ice cube melt that fast.
So what do you think's happening then? If this one's colder, why do you think it's melting so fast? Definitely supposed to take the temperature beforehand because it's supposed to be the same temperature.
Well, ice.
Just for the so you know it's supposed to be the same.
Yeah. Ice would. In my mind, ice only melts when there's heat. When, it changes it to a different form.
What is heat? What do you mean different form?
Like, solid, liquid, gas.
Okay.
It just turned it from a solid to a liquid. And I've only ever seen that when heat is involved.
Well, what's heat?
Heat's an energy.
Okay.
The way that the light, the matchstick, matches because of that heat with the friction. That was the energy that caused it to light up. That's what heat would be an energy, I think.
Is heat hot or cold?
Heat's hot.
Okay.
Heat's hot.
How do you measure heat?
Me? Temperature and feel?
Okay, temperature and feel. That's two solid ways to measure heat.
Yeah. Like,
Okay.
If I touch a flame, it's gonna burn.
Okay.
And if I need a
But we
temperature.
touched this cold thing,
Yeah.
and it made this cold thing.
So that just doesn't make what I
just
said.
mindfulaced you. Okay. So what do you think's going on?
I don't know. That was crazy because that melted fast.
This one like hasn't even done anything.
Yeah.
Like. Look at that.
That happened really fast.
So what could be going on?
There's no internal heat in there? No, because I would have felt that.
Yeah.
Like I would have felt heat on it. It's like freezing cold right now.
Yeah. Oh yeah, I definitely was supposed to measure that before the.
Okay, well, this is metal. This is plastic.
Mhm.
Metal. Maybe contains heat? No, I don't.
What do you mean? Don't say no. What are your thoughts? Just you can spitball.
I was thinking like maybe the metal like is containing some heat in it somehow. Because definitely when you heat something metal, like a pan, it can hold it. It can hold the heat, and that's why you're able to cook on a pan or put a pan in a campfire and cook something in it. You can't do that to plastic.
Okay.
It'll just melt. It can't contain the heat.
Okay. Can't contain it. Okay. Yeah. I like that.
Okay.
So, why can't it contain the heat?
Just what it's made out of. Just
So
like earlier when I was cooking and I put oil in a plastic bottle and it just like melted it. It couldn't do it. It couldn't handle it. It was just way too much for it.
Okay.
And then I mean obviously the pot that I was boiling the oil in could take it. And that's made out of metal.
Okay.
But it was cold. It was cold when I touched it.
So it's like,
Maybe.
it's weird.
But it melted very fast. That's what I don't understand.
So it's like, it did something when it was, so it got a liquid hotter
Yeah.
and it made a liquid. Did it make the ice colder or warmer?
It made it warmer, and that's why it melted.
Okay.
If it made it colder, it would stay like this, or not colder. If it made it, because this isn't making it colder. It's going to slowly melt because of its surrounding and stuff. But it's not making it melt rapidly like that.
So negating the fact that I took the temperature at the wrong time. These were the same temperatures beforehand.
I believe you.
Okay. So if they were the same temperature beforehand, what is it about this metal? Like, what do you think is about the metal that's making it melt faster? That's different than the plastic. Like, so it's like it got a liquid hotter and it got a liquid colder. I'm so confused.
Because like this feels colder to me
Mhm.
altogether.
Well, yeah. Now that we melted an ice cube on it.
Yeah.
So now we even measuring it. This one got colder, right?
Yeah.
So why did it get colder then?
It's true. This doesn't soak up anything the way the metal does.
What do you mean soak up anything?
Plastic. It doesn't absorb.
Absorb what?
Does the ice cube have energy?
Does it?
It didn't absorb the temperature the way the metal one did.
Didn't absorb the temperature. Okay. What is temperature?
Well, because the ice cube was cold, and as it melted, this absorbed the cold from the ice cube, I think.
Okay. Okay. How did it absorb the cold? How do you think it did that?
Shit. I don't know. How did it absorb the cold? I know it absorbed it somehow.
If you know it, you don't. So how do you think it did it?
It just, whatever the metal's made out of, it's made out of metal. The metal just has that property where it could just.
Okay. Well, what do you mean by property?
That property where it can adapt to, like, its temperature to whatever's like making contact with it. Because if you put, I don't know, if you were to make like a mini campfire and put a little wood and light it on fire and keep it going, it's gonna get hot and you won't be able to touch it.
Okay.
It's gonna absorb whatever contact it's making.
Okay.
Shoot, that's what I.
You can curse. It's okay.
Okay. Gosh darn it.
Gosh.
If I put beer on it, it's gonna get drunk. Just kidding.
We don't know.
We don't know.
Maybe Mel's got that part. So you said it's got like a property, but like, so what kind of like what do you mean by that? Is there something special about metal that's different than plastic? Is there something that metal has that plastic doesn't? Or is it metal does something that plastic? I'm not sure what you mean by the property, I guess.
Well, metal's an element, right? It's on the periodic chart.
Metal? Or
Is it?
types of metal?
Types of metal I know are. There's
Okay.
like a whole column of them.
Okay. Yeah.
Gosh, I need to take a science course.
Only take what you want.
I do a lot of writing there. And metals have their own properties. I don't know how to put a property into a description. I feel like a metal is more solid than a plastic is. I feel like plastic has its own little holes and stuff, and
What do you mean by holes and more solid?
Plastic is more vulnerable than metal. Like, I could break the plastic, I can't break the metal. I feel like the metal's obviously a lot stronger, and it has its own.
So what do you think makes it stronger than the plastic?
I don't know. That I feel like it's more pure than a plastic. Plastic's made out of different things.
Okay. So, like, what do you mean by it's made of different things?
Plastic's just, it's like fake.
It's like
Plastic's fake. Metal's just real.
Okay.
I don't know.
Real? No, I mean, yeah, so, but like, we can like make different types of metals, like
Yeah, there's.
make different types. So we can make different types of plastic. I think I understand what you're saying with that. So I kind of want to get back to, like you said, it's like how it's like the tiny holes and stuff. So like,
Yeah.
you think there's some like tiny holes in the plastic,
Yeah,
or do you
there's
think there's
little
like
tiny holes.
spaces? Is there tiny holes in this? Like, how big do you think these holes are?
These are a lot bigger than that one, I feel. Like, this is probably more, it's like porous, you know?
More porous? Okay. So yeah, okay, so like porous, like sponge kind of like.
Yeah.
Do you think you can like see the hole? Do you think it's like?
I don't think it's something I could see. It's just the way it's made out of. It's just plastic. It's just like, it's hard to explain. I guess like in my mind,
That's what I want to
like,
hear.
people recycle plastic because they can make it into other things. Like, you can form it into other things. You don't go and recycle metal, really.
Okay. Okay. So what do you think about these? So the tiny holes and stuff, like, and how it's like, what do you think makes the difference in terms of like energy, like transfer of energy? Does it have?
That's where I get mixed up, because because like, let's say this metal had the pores, then it'd be easier to transfer that energy, and it'd be easier to melt that ice cube as fast as it did. That's where I'm kind of contradicting myself there.
Oh, okay. So you initially think that this has more
Pores,
but because this melted faster, you think that this might.
Yeah, because that's how I feel like if the more pores it has, it can move energy throughout it and melt that ice cube.
Okay. So how do you think the energy moves through it? Like, how do you think it's going? Like, how is it moving through the pores to melt the ice cube?
I don't know. I think I'm just still like, I'm so amazed that it melted the ice cube that fast.
Okay.
I wish I could understand how it melted it so fast, because I've never seen that.
Well, why do you think it did? What do you think? Why do you think it did it?
Well, to me, I would have thought that there was heat there, but there wasn't. They were the same temperature, and it only felt colder because it's metal. But what does it being metal have to do with it? Like,
So you said heat was an energy, right? When we did the matches
yes.
and stuff. So was there heat involved in this at all?
No.
There wasn't. Okay. Why do you think that?
Maybe there's a certain amount of heat.
Okay.
There had to be a certain amount of heat. I'm sure there's a certain amount of heat to everything.
Okay.
Just because it's not on fire doesn't mean there's no heat.
Okay.
Is heat I'm thinking here.
Go for it. Think away.
Heat does heat necessarily mean hot? I don't think so. I think heat and hot are two different things now.
Okay. Why do you think that?
'Cause heat can be any temperature. Heat can be any temperature. But heat is not what. How do I explain it? Heat and hot are two different things.
Okay. So. Okay, cool. Right on. So, was there heat involved?
Yes.
Okay. So.
I'm changing my answer to yes.
Okay. So if you think there's heat.
But it wasn't hot.
But it wasn't hot. So what happened to the heat?
The heat. Well, the ice cube had to adapt to whatever temperature this metal was. But I'm just trying to figure out why it did it at a faster rate than this.
Alright, this thing's still trying to.
Yeah, it's still going.
So.
The heat transferred to the ice cube to make the ice cube the same temperature as the metal.
The heat transferred from where?
From within.
From within.
I don't know, maybe from. I'm wondering if. Because the metal had to have been room temperature. Had to have been room temperature, and then. Shit. What was the question?
What do you think happened to the heat? So where'd it go? Because you said the heat got transferred to the ice cube?
Yes.
And from where did it get transferred from?
From the metal, from.
Okay. So how did
whatever heat was being stored in the metal.
So so there's heat stored. So, but if these two things are the same temperature.
They're made out of different things, though.
But did this store more heat than this? But it's the same temperature.
This has the ability to store. I don't think the plastic does.
Okay. What do you mean by the ability to store?
It's just one of its. It's just one of its characteristics. I have no idea. It's crazy.
Okay, cool. No, all right. Well, I'll tell you what. Let's go ahead and move on to the next one because I think we're in a good spot. Like you're killing it.
Oh God.
You're doing awesome.
Are you gonna get to explain this to me later?
Yes, I can explain it to you after
Oh my
we're
God,
done.
thank you. Because it's gonna hurt my brain. I will not be able to sleep if I don't know what's going on.
That's funny. It's gonna hurt my brain.
It's gonna hurt. It will.
Okay. Clean up that mess real quick. It's crazy. You know how long you're gonna say we're just sitting at our door?
She probably is.
This isn't too bad so far, right? You doing alright?
Yeah, I'm fine. It's fun. It's just, I've never had to like think about these things.
It's fun.
Which is crazy because this is stuff that I deal with like plastics and metals and heat and.
It's like everyday stuff. It's kind of weird, right?
I'm kind of hoping I went through a breakthrough with myself when I said that heat is not necessarily hot.
I liked it.
I think that's a thing. I hope it's a thing.
I hope it's a thing. That's okay. Okay. Okay, 1 second. Alright, cool. I can just use this. Sweet. Alright. You ready? What do you think's happening to the energy in this right now? And what happens when I stop? So I'm gonna keep doing this a bunch of times. You can like think about it, look at it, and just tell me like just as soon as you start getting ideas. Just start. What do you think happens to the energy when I'm pushing it?
It goes from.
Stop.
It goes from.
Why does the block stop moving?
Because you stopped. You stopped giving it force.
Okay, so I stopped giving it force, so that's why I stopped moving.
Yes.
Okay. So.
There's still force on it though.
Okay.
Even as it's sitting there.
So there's still energy on it?
Like potential energy.
What do you mean?
I know gravity is acting on it. It's on a table.
Is gravity energy?
Gravity's a force.
Okay.
Is a force energy? No, it's not.
Okay. So, is there energy in it right now? Oh, no.
Yes.
Okay, so there's energy in it now and now. How about now?
No.
Where'd it go?
That's when it's called potential energy.
What's potential energy? Why? And we've said it a couple times. I just want to keep reiterating
That it could happen. That it has the ability to do it. It just needs a force to act on it.
Oh, okay. And so then, me doing this. So
That's
now am
kinetic.
I okay? So am I causing the energy, or does the box have energy? What do you think?
You're supplying the force. Yeah, you're giving it energy.
So does the box have energy, or am I? So it has no energy now, and I'm giving the box energy right now. Is that what you're saying?
Yes.
And when I let go, the box has no more energy.
It has potential energy. It just needs.
Okay. So did it have potential energy right here?
Yeah.
So it's saying it has potential energy.
And then kinetic, and then when you stop, it's potential again.
Okay. 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 I like it. We can go on. We can go on the next one. I'm not the biggest fan of this. I'm gonna refine this one a little bit. Cool. All right, you ready? We're almost done. All right. Ugh. Far on camera. All right. So,
Oh no.
what do you think's gonna happen?
You're gonna drop it, it's gonna bounce.
Okay. Boop. So why did it fall?
Like from up here to here?
Hmm?
Why did it fall? Because you let go of it and the gravity just like pushed it down to the table, and then shit, does the table have energy? Transferred whatever there was into the ball to make it go back up and down and up and down.
What?
I don't know why,
What?
but when you did that reminded me of those little metal balls that go like this.
Oh.
Yeah, and it'll keep going because it goes from one ball to the next and then.
Okay. So then what happened? Why didn't this ball it didn't bounce up as high each time, right? It eventually.
No, it ended up, it went high, low, got lower.
So those balls keep going back and forth. So why is this one stopping?
Because there's the energy, it stops transferring. So.
Transfer. Where's the energy? Is there energy right here? And then, oh.
I feel like there's only energy when it's making contact. No, because if there's constant energy making contact, if there was constant energy as contact was made, it'd keep bouncing. Why does it stop?
Where? Okay. So, what kind of energies have we talked about so far? So right now you said there's no energy. And there's energy when it hits the table.
I guess potentially there is energy.
So potentially there's energy.
Yeah, because that's what I said about the match, that potentially there's energy, but it
Okay.
needs that force to make it, happening, to
Okay.
make it kinetic.
Okay, so is there a force now? When I drop it?
Yeah.
What's the force?
Gravity.
Okay, so.
And then there's also force from the table kind of pushing it up also.
Okay, so as it hits that, there's a force pushing it back up.
Mm-hmm.
So. Okay. So there's energy here, and then is there energy here?
Yeah, that's what makes it bounce.
That's what makes it bounce back up.
Yeah.
Okay, so why doesn't it bounce back up as high? Does it have the same energy throughout the whole thing?
No.
Okay.
Otherwise, it would keep bouncing at the same height.
Okay. So then where does it go? Why doesn't it keep bouncing at the same height?
Where does it go? Jeez.
Put it bounce off if you want
I wonder if.
it. Wonder what?
I was just gonna say, I wonder if there wasn't anything on the like if we just had a big old surface and it wouldn't keep bouncing though. I know if it was just on a big old open space, it would still fall.
Bounce on the
It would, like, if we had like a whole floor with nothing like to stop it and distract it,
just a hole.
like just a big old space. Because when it's bouncing, it's moving that way and it gets kind of stopped there and it rolls away. But I'm sure even if there was nothing there in a big open space, it would still
So why does it
stop.
bounce over there and over there?
That's true. Why is it? It's moving.
So if we bounce, so you're saying if like it didn't like why is it moving?
Yeah. There has to be. There's other forces acting on it.
Okay. Well, okay. So quick question. So we said there's a potential energy right here, right? That's what you
Mhm.
said. Then we drop it, and there's a kinetic energy. Is that what you said? I'm trying.
Yes,
Okay.
I know it is.
Okay. So then right here is there energy as it like when it bounces.
Yeah, there's energy transferring it.
Okay. So
Transferring into
is there
the
the
ball.
same amount of energy right here as there was right here?
No.
Okay, so was there more energy up here? Was there more energy after like once we hit the table? What do you think?
It's gonna sound so stupid.
No,
I feel
nothing
like
sounds.
I feel like there's more energy up here because you're giving it momentum. You're making it fall.
Okay, so make it fall. So then it's falling, and then so what?
So since there's more up here and there's less down here,
where'd it go?
that's what makes it. It's that velocity where it fell. I mean, that
Okay.
speed that it fell at, and
So is it losing energy as it falls?
yes,
So is that why it's less?
yeah, that's why it's less, and that's why it's all bouncing. I think.
That's also why it's bouncy. So you think it lost energy, but where did that go? Like, did it just be like, I'm out?
Like peace. No, I'm just kidding. Pretend I didn't do that.
That's going.
That was
real.
embarrassing. Oh no, I finished. It's that energy. I wonder if energy can transfer into something different. I mean, because kind of like when I lit the match, and once it was out, like you asked where did that energy go, and I had no idea. I'm wondering if that energy can transfer into something different, into. Oh.
Could what do you think it could so what do you mean transfer into?
Like just move somewhere else.
Like where would it go?
That's where I'm trying to figure out. Where would it go?
Well, what do we have going on? So we have it up here. So this is before we first thing go here. So drop it, and you're saying there's less energy right here than that first. So after that bounce and it comes back up, is it going to go to the same height?
No.
No. So it's going to be at a lesser height, right? Is there the same amount of energy in this when it's up here as there was the first time before it bounced?
No, because if I'm following through with what I said, I'm saying that there was the reason was because of that that velocity or the height, and if it's at a different height, then it's gonna have a shorter distance to travel.
Okay. So then is it going to come back up to that second height the next time it bounces?
Now it's gonna be lower and lower each
Lower
time.
So is it losing energy as it, like where is it going? Is it losing energy as it falls, as it bounces, when it's back up? What do you think?
As it hits the table or the ground or whatever it's hitting, that's where it's losing the energy.
Okay. So that's where you think, so as it hits, that's where the energy's getting lost.
Yes.
Okay. So where do you think it's going, or what's happening to it?
Gravity's just pushing down on it.
Well,
And
what I meant the energy. What's happening to the energy? Where'd the energy go? If we're saying we're losing it, how do we lose it?
it's just being transferred somewhere else, is what I feel.
Okay. Do you have any ideas of where you think it might be transferred to?
Oh, I have no idea
Nothing?
where it's going.
What?
That was the same thing with that. I had no idea where it was going.
Okay. Well, let's see. So, like we said, so you said it's losing energy as it bounces, right?
Yeah, as it's hitting the.
So something about when it hits causes it to transfer energy somewhere. That's what you're saying.
Yeah, it's
Okay.
losing itself.
Is it transferring energy to like the air, to the table, to like what do you think?
If I was to the table, I think.
Okay. Why would you say that?
That's what it's making contact with.
Okay.
I mean, technically with the air too, but as maybe it's just going through the air, it's losing its its force there. It's losing its speed as it bounces, and it's. But I'm wondering if it's going to the table, if the energy is like, it's. I would say to the table, but if energy was being transferred to the table, then I feel like the table would transfer the energy back into the ball.
Okay.
You know what I mean?
What do you mean?
Like, if the energy is being transferred to the table, I feel like the table would transfer it back up into the ball and keep it going. But that's not what's happening.
Well, so you're saying that
like it would just go back and forth.
It's going back and forth. Is that why you're saying it's bouncing? Is that what you're saying?
Yeah. That's why it's bouncing, but as it's going, it's losing energy. I just don't know where the energy is going.
Okay. So you think there's a transfer of energy from the ball to the table,
and the table to the ball,
but you think there's also a loss of energy because the ball's not.
It's not. It won't keep going. It's not going at the same height, and it stops eventually.
Okay. So, but you're not sure where that energy is going. Once it's. You're saying when it hits the table, that's when it loses some kind of energy. That's why it doesn't go back up as high. So you're just not sure where it goes when it hits the table, when it's going to the table and then back to the ball.
Right.
That's what you're saying?
Yeah.
Okay.
I don't know where it's going.
Want to try? Want to just throw a dart? What do you think? You gotta have some kind of ideas in that brain of yours.
I don't have a brain.
Oh, don't say that.
Just kidding.
Well, the scarecrow didn't have a brain. Maybe he had one eventually.
It's going from here to here. I feel like it just becomes potential energy again. Maybe it becomes stored again.
Okay. So it becomes stored again. Like it's go.
Like into the ball.
Okay. So it's going from like potential to. Is it still potential when it hits? Is that what you're?
No. Once it's let go, it doesn't. It's not potential anymore.
Okay. So what is it?
Because it's in motion and everything. It's not potential
Okay.
anymore.
Okay. So what is it then? What kind of energy? Kinetic energy. Okay. So then it goes from kinetic energy and it stays that after the first bounce. Is that what you're saying?
Yeah, it's still kinetic energy as it's still in motion, I feel. And once it's still again, it just becomes potential again.
Okay. So is there a moment when the ball bounces that it's still on the table?
Is there a moment when the ball bounces that the ball's still on the table?
Like when the ball bounces on the table, it has all this going one direction, but then it just goes back the other direction.
Yeah, the energy itself is being bounced with the ball. It's going from this to this to this to this.
So is it staying as kinetic energy the whole time?
Until it stops moving.
Okay.
But maybe not the same amount.
Right. Okay. Yeah. You don't think it's the same amount, but we still don't. We're not sure where it's going. Right.
Mm-mm.
No clue. Okay. You want to throw in the towel?
Yeah. Oh my god, I don't know. I need to know what's happening.
Alright, let me turn off the camera. That way, if I explain it wrong to you, I don't have evidence now.